Hello viewers, welcome to this next lecture on this NPTEL MOOC course on mathematical portfolio theory. So far we have been talking mostly about equity based portfolio optimization, that means a portfolio optimization involving risky assets, and we just only consider a scenario where you could include only one bond to a portfolio of several risky assets or stocks. So now we are going to focus on a new topic with an emphasis on a portfolio that comprises of several bonds and exclusively of the bonds and the risk associated with the bond. And remember that we had talked a little bit about bonds earlier and what is the source of this risk, and we have discussed several possibilities possible sources of risk in case of a bond from the point of view of a bond holder. And in this part of this course, we will mostly emphasize on the topic of the sensitivity of the bond prices vis-a-vis the interest rate. So, remember what happens is that suppose you are investing in a bond for a certain period of time, and after a point of time you decide that you want to sell off your bond to somebody else. Now, what might happen is that you, based on the interest rate that was initially applicable to the bond, you have a certain expectation or estimation of what the price of the bond that you will get in the intermediate time points. However, in the intermediate time point the interest rate might have changed, and this will have an immediate ramification on the price of your bond. So, what might happen is that if the interest rate goes up, then the bond prices goes down and you will lose money as a bond holder. But in case the interest rate goes down, then the price of the bond goes up and then you will get a gain as the bond holder. And this is something that we are going to discuss in detail in today's class. And we will begin with a prelude to a background to bonds in general, including the pricing of the bond, and then we will move on to the concept of duration, which is a measure of risk for the for a bond. And the eventual goal for this part of the course is to look at two important measures of risk, namely duration and convexity, and how it is applicable in case of an optimization of a bond portfolio, the term for which is known as immunization. So, accordingly, we start this lecture. So, first of all, let us talk about bonds, and we start off with the definition of a bond. So, a bond is a financial instrument of debt involving two parties, namely the creditor and the debtor. So, in this arrangement, the creditor or who extends the credit or the purchaser of the bond lends a certain amount of money for a specified period to the debtor or issuer of the bond, and in return the debtor issues a bond to the creditor which promises the repayment of the amount borrowed from the creditor along with additional payment known as interest. So, accordingly, we list the relevant terminologies as follows. So, the first one is the following, that the amount borrowed by the debtor from the creditor is called the principal or par value or face value. The second terminology is the regarding the time. So, the time period for which the money is borrowed by the debtor from the creditor, that is the time period of the bond is called the maturity of the bond. Thirdly, the payments made by the debtor to the creditor could be a single payment or could be a number of periodic payments or coupons, and these are called a zero coupon bond and coupon bond respectively. So, the 3 points that we are talking about is, first of all, we talk about the amount borrowed, and this is what is known as the principal or par value or face value, and the time period for which the money is borrowed, this is known as the maturity of the bond, and the payment made by the debtor to the creditor. If those payments are a single payment, then the bond is called a zero coupon bond, and if there are a number of periodic payments, then the bond is known as a coupon bond. So, we next come to the interest rates and introduce a few notations. So, let the time at which the bond is purchased and the time at which the bond matures be denoted by small t and capital T respectively. Then capital T minus small t, which I will denote by h, this is called the holding period or the investment horizon of the bond. Now, depending on H, we now consider several cases in order to define the interest rates. So, the first one is when H is less than 1. So, we enumerate all this. So, the first one is H less than 1. So, let the price of the bond at time little t and the par value at time capital T. So, the single payment here, this is sometimes referred to as the par value. So, this par value at time t for a 0 coupon bond be denoted by BT, B of little t and B of capital T respectively. Then the annual rate of simple interest for the bond is defined as R is equal to 1 over capital T minus small t is equal to into B of capital T minus B of small t over B of small t. So, here the term within the parenthesis is the return during the investment horizon H in number of years of the investor. And observe that from this relation B of capital T is equal to B of little t into 1 plus R into capital T minus small t. Let us now look at the second case. If your H is greater than or equal to 1 and is an integer. So, we looked at the case H less than 1 and now we will look at two sub cases of H greater than or equal to 1 and this is an integer. So, in this case we have the relation B of capital T is equal to B of little t into 1 plus R raised to capital T minus small t. And for the third scenario of H being greater than or equal to 1 and is not an integer, in this case we have the following, that capital T minus small t will be some alpha capital T minus small t plus beta capital T minus small t, where so it is capital T minus small t is getting decomposed into two terms, where the first term of alpha capital T minus small t and beta capital T minus small t. These are the integer. So, basically I take capital T minus small t and decompose it to an integer and a decimal part. So, alpha t, t minus t is the integer part and beta t minus t is the decimal part respectively. So, accordingly we have the following. We have that b of capital T is equal to b of little t into 1 plus r raised to alpha of capital T minus small t, that is 1 plus alpha raised to the integer part similar to this term here, into 1 plus beta T minus capital T into r, something similar to this part. So, it is a combination of both. So, next let us come to what are known as the forward rates. So, let R0 t denote the interest rate today, and I will denote today as t is equal to 0, and this is the interest rate for the period starting today and going up to time little t. This R0 t is called the spot rate. Okay, let us introduce another notation. So, let F0 t capital T denote the interest rate decided upon today, that is at t equal to 0 for a loan made at time t is equal to little t up to time t equal to capital T, and this is, that means F0 little t capital T is called the forward rate. So, just to put things in perspective, so we have this time today at 0, and at time 0 we decide on the rate for a loan that is going to be applicable from time small t to time capital T. So, the decision, so the interest rate is going to be applicable from 0 to capital T as given by small t to capital T, but the rate is fixed at time t equal to 0. So, the interest rate will prevail in this period, but this will be decided at time t equal to 0. So, clearly if I take small t is equal to 0, so that means F00 capital T, this is nothing but the interest rate decided at 0 for commencing at 0. So, this is nothing but R0 t, which is the spot rate. So, also it can be shown that the spot rate between 0 to capital T, so this will become is R of 0 capital T. The accumulated interest in the period is 1 plus R0 t into t. So, if you start off with an amount of P naught, it grows up to by a factor of 1 plus R0 t raised to capital T, and this is equivalent to an investment of some amount P naught for the period with the from 0 to small t. So, then it grows up by a factor of 1 plus R0 small t raised to t, and then from this to from small t to capital T, it is going to go up by a factor 1 plus f of 0 small t capital T raised to capital T minus small t. So, that is the interest rate from 0 to small t raised to t multiplied by the interest rate using the forward rate from small t to capital T for the period capital T minus small t. This is same as the interest rate and the growth factor from time 0 to capital T. So, this relation, this relation is equivalent to the following relations. So, the first one is I can solve this for f of 0 little t capital T, and this turns out to be equal to 1 plus r of 0 capital T raised to capital T minus 1 divided by 1 plus r 0 little t raised to little t minus 1. And the second relation will be for r 0 t. So, this you can solve to be 1 plus r 0 t. So, we take the 1 over capital Tth root on both sides. So, this becomes 1 plus r 0 t, this term here, raised to t over capital T into 1 plus f of 0 little t capital T. Again this is going to be capital T minus small t over capital T. Now, let us come to the concept of valuation of bonds. So, for this we first consider a 0 coupon bond at time t is equal to 0 with the maturity, and in this case of course the maturity also coincides with the horizon in this case of capital T. So, the maturity is capital T and this is the same as the horizon. Now, let the spot rate for the bond, and remember the bond is from t equal to 0 to capital T. So, the spot rate for the bond be r 0 capital T, and the par value, and remember what is the par value? Par value was basically the payment received at the end by the creditor. So, this par value at time t is equal to capital T be denoted by B of capital T. So, as we have done before. Then if you receive an amount of B of capital T at time capital T, then the price of the bond or the amount that the creditor should lend at the initial time t equal to 0 is going to be given by B of 0 is equal to B of capital T into 1 plus r of 0 capital T raised to minus t. So, how do we get it? So, suppose that you initially start off with an amount of B 0 and invest for the time capital T. So, this will go by a factor of 1 plus r 0 capital T raised to t, and this is going to be B of t. So, getting this term on the other side gives us this relation. Okay, now that we are done with the 0 coupon bond, so we now consider the case of a coupon bond which pays or has payouts of periodic coupons in addition to the par value. So, in the 0 coupon bond you only had the par value, but now in case of coupon bonds in addition to the par value you will have periodic coupons. So, accordingly we need to have a notation for this coupon. So, in this case we let the coupons be denoted by C of t for t is equal to 1 to all the way to capital T. So, these are the bunch of periodic coupons being paid at time t equal to 1 to all the way to capital T. Note that, so you have to be very careful that when we talk about the coupons, we have to be careful about the last coupon. So, note that C of capital T is not just the last periodic coupon, but it is the last coupon plus the par value of the bond B of capital T. Further, let R0 t be the spot rate of the horizon for t is equal to, so for the horizon little t, for little t equal to 1 to all the way to capital T. Then the price of the bond at time t is equal to 0 is given by the following. So, it is going to be C of 1 into 1 plus R 0 1 raised to minus 1 plus C of 2 1 plus R 0 2 raised to minus 2 all the way to the final coupon C of capital T into 1 plus R 0 capital T discounted back to time 0. So, this is the basically from the this is essentially what you had seen in case of the 0 coupon bond, and this entire sum is going to be equal to B 0, and this is going to be summation in the compact form summation of C t into 1 plus R 0 t raised to minus t, t is equal to 1 to capital T. We now consider a particular case as far as the coupons are concerned, where the coupon bond pays coupons of identical amount, that is all C of t is equal to C for t is equal to 1 to all the way to capital T, and the par value as before is B of capital T at time small t is equal to capital T. Further, we let the spot rate R 0 t be denoted by some little r for t is equal to 1 to all the way to capital T. Then B 0, what was B 0? So, B 0 was summation t equal to 1 to capital T from here into C of t into 1 plus R 0 small t raised to minus t. So, in this particular case this becomes summation t is equal to 1 to capital T C of 1 plus R raised to minus t plus B of t into 1 plus R raised to minus t. So, this can be rewritten as follows, that B 0 is equal to C over 1 plus R. So, I basically be use of sum of a geometric series into 1 minus 1 plus R raised to capital T, and for the final term we have the same thing, the B of capital T divided by 1 plus R raised to capital T. So, we replace the C of t with small c here and R 0 t with R, and we have done some algebra and we have obtained this form. We observe that B of 0, this is going to be C over R as t tends to infinity. So, in this expression, if we let t tends to infinity, we will have B 0 is equal to C over R. So, in practice, you might wonder what is this infinite maturity. So, in practice, the scenario of this t tending to infinity is referred to as what is known as a perpetual bond. Okay, so coming back to this relation, so we finally get that B 0 over B of capital T, that is dividing both sides by B of capital T, this will be C over B of capital T on the numerator divided by 1 plus R into 1 minus 1 over 1 plus R raised to capital T plus 1 over 1 plus R raised to capital T. So, this brings us to the concept of yield to maturity. So, we start off with a definition, and the yield to maturity. So, we bring into the observation that the yield to maturity is an interest rate R star such that B 0 is going to be summation C of t into 1 plus R star raised to minus t, where t goes from 1 to capital T. Then for the particular case of C of t is equal to little c, for t is equal to 1, 2 all the way to capital T, the yield to maturity is an interest rate R star such that B of 0 is equal to summation C into 1 plus R star raised to minus t, t is equal to 1 to capital T plus B of capital T into 1 plus R star raised to minus t. So, we next come to the concept of what is known as duration, and this is the point where we start about the bond portfolio management concepts. So, duration is a measure of risk. So, it is a measure of risk just like we had in case of stock, it is a measure of risk that is associated with a bond and is a very critical component of bond portfolio management, particularly what is known as immunization, and this is a concept that we will deal with a later stage. So, the duration of a coupon bond is defined as follows, and the definition is: the duration is summation of t is equal to 1 to capital T 1 over b into t of C of t divided by 1 plus r raised to t. So, again we note this in the particular case. So, let us see what the duration turns out to be in the particular case of C of t is equal to C. And so, here I must just clarify one thing, that C of t is actually going to be C plus B for t is equal to capital T. So, just to remove any ambiguity as far as this notation is concerned. So, so C of t is equal to C for t is equal to 1 to all the way to capital T, then the duration is given by d. So, what does this relation reduce to in this particular case? So, this is given by d is equal to summation t is equal to 1 to capital T small c over b, because this is a constant c now, into t over 1 plus r raised to t plus 1 over b into t of capital B t divided by 1 plus r raised to capital T. Now, this brings us to the question as to why duration is defined. So, I have sort of suddenly introduced this definition, and I need to now justify as to why the duration is defined in this manner. Now, we will see that it eventually turns out that the duration as defined above measures the sensitivity of bond prices to yield to maturity. So, to begin with, we denote B of 0 is equal to B. Now, recall that the price B of the bond as a function of interest rate R is given by B of R is equal to summation C t into 1 plus R raised to minus t, t from 1 to capital T. So, therefore, what is going to be the sensitivity of the bond price as a function of R? So, for that we take dBr with respect to R, and this is going to be summation of minus t of C of t into 1 plus R raised to minus t minus 1, t is equal to 1 to capital T, and this is minus of summation t is equal to 1 to capital T, t of C t into 1 plus R raised to minus t divided by 1 plus R. And this is going to be equal to minus B over 1 plus R. So, what I do is that I multiply and divide by 1 by B into summation C of t into 1 plus R raised to minus t, t is equal to 1 to capital T. So, there is a t here. So, hence we can write, so you observe carefully what is that going to be the definition of a duration. So, this is the definition of a duration 1 over b into the other quantity. So, what you observe here is that this quantity here that you have, this is going to be our duration. So, hence we can write that dV dr is going to be minus B into 1 plus R into D, which implies that D is going to be minus of 1 plus R over B into dB over dr, and this can be rewritten as minus of dV over B, that means the rate of change in the bond price proportional to the. So, this is going to be d of 1 plus R over 1 plus R. So, this is going to be the change of rate of change of the bond price over the rate of change of the interest rate with a minus sign, and this is the same as the definition of duration. So, this, and since this gives us the proportional change in the bond price relative to the proportional change in the interest rate. So, it gives us the sensitivity. So, this entire quantity gives us the sensitivity of the relative change in the bond price vis-a-vis the relative change in the interest rate, and that is the reason why this is taken as a measure of the risk of the of a bond price as a function of the interest rate. And this turns out, and that is the reason why it is this form that had motivated us to define the duration using this formulation. So, thus the interpretation is that the relative. So, observe that this is dB over B and d of 1 plus R over 1 plus R. So, this relative or percentage change in the bond price is the negative of the duration. So, if we just look at dV over B, this is going to be minus d, negative of the duration multiplied by the relative or percentage change in the growth factor, that is 1 plus the yield to maturity. So, observe that dV over B is going to be minus d multiplied by d of 1 plus R over 1 plus R. So, this is what I said, that the relative change in the bond price, that is dV over B, is the negative of the duration, that is minus d, multiplied by the percentage change in the growth factor, that is percentage change in the growth factor, that is 1 plus R. So, this means that for a certain percentage of increase in 1 plus yield to maturity, the corresponding percentage change in the bond price. So, that means for a change in this as given by this term, the corresponding change in the bond price decreases as the duration goes up. So, as the duration goes up, this term minus d will become smaller. So, accordingly this will decrease. So, this change in bond price decreases as the duration goes up, and vice versa. So, further this in turn means that a bond with low duration is desirable from the point of view of the bond purchaser. So, a fallout of this definition is what is known as the modified duration, which is given by dm is equal to d over 1 plus r. So, this brings us to the end of today's lecture. In today's lecture, we started off a new topic, that is on bond portfolio optimization, and we focused primarily on the background to this, namely we looked at what is the interest rate, what is yield to maturity, and then what is how do you determine the price of a bond in case of bonds which have 0 coupons, that means there is only final payment, and in case of coupon bonds. And then we introduced the definition of a duration and looked at a justification of why the duration is defined in that particular manner, and why is this an indicator of the risk associated from the point of view of a purchaser of a bond. So, in the next class we will continue our discussion on this by looking at several properties of duration, and then we will also talk about the duration in case of a portfolio of bonds. Remember that this is a course on portfolio theory. So, we will look at the duration in the paradigm of a portfolio comprising of several bonds. Thank you for watching.